Our world it's increasingly run by AI, right? From smart cities to self-driving cars, it's everywhere. But here's the thing. As these systems get smarter, they also become much bigger targets for attack. So today, we're going to dive into a really fascinating system called DeepBlockIoTNet, which is all about making our AI not just smart, but truly trustworthy.
So let's just start with that central question. Think about it. When an AI is making a split-second decision for a self-driving car, or maybe managing a city's power grid, the stakes could not be higher. So how can we really be sure that the data it's using and the decisions it's making are secure and correct?
And that, right there, is the core problem. It's like the very thing that makes these devices so incredibly smart is also what makes them a target. They can be attacked, their data can be poisoned, and the whole system can fail. So the smarter they get, the more we have to guarantee they're safe.
Okay, so this challenge gets especially tricky in what we call cyber-physical systems, or CPS for short. Just think of these as systems that blend the digital world with our physical one. An autonomous car? Perfect example. They have to sift through just massive amounts of data from their sensors, and they need to do it with pinpoint accuracy and pretty much zero delay to make, life or death decisions.
So you might be wondering, how did we try to solve this before? Well, a couple of approaches have been tried, but as you're about to see, they all have some pretty major drawbacks, especially when security and speed are everything. So this slide really shows a fundamental trade-off we've been dealing with. On the one hand, you've got cloud intelligence. All the data gets sent to a big central server. And yeah, it's got all the processing power you could want. The problem? It's slow. Sending all that data back and forth, that's what we call high latency. Then there's edge intelligence, which tries to fix that speed issue by doing the processing closer to the devices themselves. Much faster, for sure. But, and this is a big but, it's still got a huge weakness. And here it is, the fatal flaw. See, both of those old systems, cloud and edge, they both rely on one central controller. And if that single point of failure gets attacked, or just fails, the whole system goes down. And that's a risk you just can't afford in these critical systems. So to get around this, researchers did something really clever. They took two super powerful technologies and mashed them together. They teamed up the brains of artificial intelligence with the security of blockchain, creating a brand new team for this very new challenge. All right, first up, deep learning. You can pretty much think of this as the brains of the whole operation. It's this incredibly powerful type of AI that is just amazing at finding complex patterns in huge piles of data. This is the part that lets a system, say, spot a stop sign in a video feed, or figure out what a bunch of sensor readings actually mean. And its partner in crime is blockchain. Think of this as the system's shield. Basically, it's like a shared digital logbook that's almost impossible to hack. By spreading the records out across lots of different computers, you don't need a central boss anymore, and the data becomes incredibly tough to mess with. It creates trust without a boss. Okay, so you've got the brains and you've got the shield. But how do they actually work together in this DeepBlockIoTNet system? Let's actually break it down and see how it pulls off being both smart and secure, all without that single point of failure. Okay, this diagram gives us a great high-level look at the structure. So down at the bottom, you've got your IoT devices, the cameras and sensors actually gathering the data. Then in the middle, you have the edge nodes. These are the local devices that do the heavy lifting, the actual AI training. And then at the top, the blockchain server isn't a single boss, but more like a decentralized referee, making sure everything is trustworthy. All right, let's walk through exactly how this works, step by step. Okay, first, each device, they call it a learning agent, it trains its own little AI model using its own private data. Nothing gets shared yet. Then it encrypts that little update and just broadcasts it out to the network. This is the cool part. Other nodes in the network then get to vote on whether that update is legit. Once it's verified, all those good updates are bundled together into a secure block on the blockchain. And finally, all the devices download this new block to improve their shared global AI model. It's collaborative learning, but without a central teacher. All right, I know this diagram looks a little intimidating, but don't worry about all the little details. The core idea is actually pretty simple. Basically, a device uses its own secret private key to digitally sign its update. It's like putting a unique, unforgeable seal on it. It then sends that out. The other nodes can then use the sender's public key to check that signature and make sure it's authentic. Then, through a majority vote, the whole group decides if the update can be trusted. And that right there, That decentralized validation, that's the magic trick that makes this whole thing so secure. So that all sounds amazing in theory, right? But the real question is, does it actually work in the real world? Well, the researchers actually built a prototype to test it out, and let me tell you, the results are pretty darn compelling. First up, let's talk accuracy. So a more traditional, centralized system, it was hitting about 65% accuracy. But with DeepBlockIoTNet, where all the devices learn together securely, that accuracy shot up to around 80%. It just goes to show, more devices working together means a smarter system overall. All right, next up is latency. Basically, how long does it take to make a decision? The old cloud model, it was taking about 57 milliseconds. But because DeepBlock IoTNet does all its thinking right there at the edge, close to the action, it slashed that time down to just 42 milliseconds. And when you're talking about a self-driving car, every single millisecond is a huge deal. But honestly, this next result is the real showstopper: security. With the old centralized system, an attacker had a 40 to 60% chance of success. That's terrifyingly high. With DeepBlock IoTNet, thanks to all that decentralized voting and encryption, the chance of a successful attack plummets to less than 10%. I mean, that is just a game changer for security. Okay, so there's always a trade-off, right? Nothing's ever perfect. And the researchers are totally upfront about it. It turns out, running all those blockchain security checks does use a little more CPU and memory on the devices. But let's be real. When you look at the massive gains in accuracy, speed, and especially safety, it's a price that's absolutely worth paying. So what's the big takeaway here? I think it's that systems like DeepBlock IoTNet are completely changing the conversation. It's not just about making AI smart anymore. It absolutely has to be trustworthy. It has to be secure. And what this shows us is a clear path for building that trust right into the DNA of our AI systems, right from the very beginning. And that kind of leaves us with one final big question. We've seen what this amazing team of AI and blockchain can do for things like self-driving cars, but just imagine where else this could go. I mean, think about securing financial markets, or protecting our medical records, or even making sure scientific research is totally legit. What other huge challenges do you think this powerful combo could solve next?